Dear student, today we discuss the chapter Chemical Thermodynamics. So in this chapter, we have to know certain terminologies such as what is system, means system क्या है, what is surrounding क्या है, and what is boundary. Boundary का मतलब क्या है. Now let us take a beaker. This beaker containing some hot water or water. So beaker containing some water, it is called as a system. And the remaining portion of the universe, these portions are, these are called our surrounding. So this is our system, and the remaining portion of the universe is our called surrounding. So this beaker is a part of the universe where some chemical reaction is going on. So it is that part of the universe, something is going on, is called a system, and the remaining portion of the universe is called surrounding. Now between the system and the surrounding, there is a real or imaginary surface that is called our boundary. That is our boundary. This glass, this water bottle is a system. This bottle containing some water. So this is a system. So in this bottle we have seen some water is there, but in thermodynamics we shall say in this bottle some matter is there. Similarly, in this beaker, if water is there, means some matter is there. Now, what is the definition of system, surrounding and boundary? What is the definition? System is that part of the universe which is under thermodynamic study, and the rest of the universe is called surrounding. Between the system and the surrounding, there is a real and imaginary surface called boundary. So what is system? It is the part of the universe. It is part of the universe which is under thermodynamic study. It is the part of the universe which is under thermodynamic study. Now what is surrounding? Rest of the universe. Rest of the universe is called our surrounding. That means system plus surrounding equal to universe. Now what is boundary? It is the real or imaginary surface between the system and the surrounding. I think we have understood the concept of system, surrounding and the boundary. So our next topic will be so this is our system. So our next topic will be, there are how many systems are there? There are how many thermodynamic systems are there? that is thermodynamic system. Thermodynamic systems. How many thermodynamic systems are there? So number one is open system. Number two is closed system. And number three is isolated system. For example, this is a system. This water bottle containing some matter, some water, it is a system. Suppose cap of the water bottle is open. Now we can add water into the bottle. We can remove water from the bottle. That is, we can add matter into the system. We can remove matter from the system. In other words, we can say matter can exchange with its surrounding. From the system, matter can exchange with its surrounding. It opens now. Since it open, this system can exchange matter with its surrounding. Similarly, suppose this is hot water, and after some time, it become normal positions. That is, the heat energy earlier in this water bottle, some heat energy is there. So this heat energy is given out to the surrounding. Again, we can also warm this water by supplying heat, or if you just kept on a warm water, it will become warm. So heat energy kept supplied to this. Energy can also remove from this. Again, we can say, in other words, we can say heat energy or energy can exchange with the surrounding. Here also, let us the example. So this is in this beaker, we can add matter into the system. We can remove matter from the system. We can supply heat energy to the system. We can remove heat energy from the system. Now, definition: what is the open system? A system which can exchange both energy and matter with its surrounding is called open system. I repeat, a system which can exchange both energy and matter with its surrounding is called a open system. So open system which can exchange both energy and matter with its surrounding. The next is closed system. Now, what is closed system? Again, suppose this is our system. Now, cap of the bottle is sealed. So, since it is sealed, you cannot add water. You cannot add matter. Again, you cannot taken out water from the bottle. So, matter cannot exchange, but it can be exchanged. So those systems which can exchange energy only but not matter is called our closed system. Which can exchange what only? Energy only but not matter. Now, what is the isolated system? A system which can exchange neither energy nor matter with its surrounding is called isolated system. Example is thermosflux. Now, what is isolated system? Isolated system, a system which can exchange neither energy nor matter with its surrounding. So we have understood what is open system which can exchange both energy and matter, what is closed system which can exchange energy only not matter, and isolated system which can exchange neither energy nor matter with its surrounding. So our next topic will be state of a system. State of a system. So just now we have learned what is system. So this is a system. This classroom is also a system. Myself is also a system. Yourself is your system. Now, what is the state of a system? Suppose myself considered as a system. That means state means what is my mental condition at this moment. That is the state of myself. Now, suppose for the students, exam is very near to you, but your result to be declared. When exam is coming, you are in a tension state. But when you are watching it real, you are in a happy state. That is, you are in a happy state. When exam comes, you are in a tension state. See, you are in different state because depending upon the circumstances. So students in different state depends upon its circumstances. At home, happy state. At classroom is quite sad state because they have to study. When exam comes, very sad study. In when result to be declared, very tension state. See, you have different state in depending upon the circumstances. Similarly, our this system also in a different state. For example, suppose same this is a beaker or another beaker containing some water and temperature is say 20 degree. So this water has a temperature 20 degree in a particular state. Now temperature of the beaker is increases by a 10 degree centigrade. So temperature become 30 degree centigrade. It become 30 degree centigrade. So it is in another state. Suppose this is a gas balloon. Imagine this is a gas balloon. So its temperature is 50 degree centigrade. So this much is the volume. It is one state. But when it is temperatures increases by say 30 degree centigrade, the size of the balloon become big. That is, it is in another state. That is, now this is the concept of state. State of the system changes as the temperature changes. This beaker in a particular state when it is 20 degree centigrade. This beaker in another state when temperature is 30 degree centigrade. So when temperature changes, state of the also changes. So this is the concept of state of system. So state of the system depends upon the certain macroscopic property such as pressure, temperature and number of moles. That's composition of the system. Suppose here now composition is a 20 liter of water. This much is the composition. Now we add more 20 liter, more 20 liter, it become volume become 40 liter. So it is in another state. So when composition changes, system also in a different state. Temperature changes, also it is in another state. Pressure changes, it is also in another state. Like you, when parents give less pressure, you are in a particular state. Parent gives more pressure, you will be in another state. So this is the concept of state of a system. State of a system depends upon circumstances, different circumstances. So we know the state of a system. What is state of a system? For person, it is mental condition. For this, the state is depends upon the certain pressure, temperature or composition. So our next topic is thermodynamic functions. Thermodynamic functions. There are two types of thermodynamic functions. One is state function, another is path function. Functions means such as work is a function, heat is a function. Let us understand path function. Those function depends on the path through which system changes its state. Suppose we have to go from ground level, this ground floor, to top floor of a building, so 7th floor of a building. Ground floor to 7th floor. So if you use staircase, then though you have to do a lots of work. But when you use lift, your work is totally zero. See, the work depends on the path. In the staircase, huge work. In the lift, zero work. But you have changed your state from ground floor to top floor. That is, work depends on the path. In the staircase, huge work. In the lift, zero work. That is, those function depends on the path are called path function. Now what is state function? Those function depends only initial state and the final state of the system and does not follow the path through which system changes its state. I repeat, those system or those function, sorry, not system, function, those function which depends only on the initial and final state of the system, that is your initial state and your final state, and does not follow the path through which you have changed the state, are called state function. So what is state function? Function which depends on the initial and final state of the system and does not follow the path through which system changes its state. What is path function? Which depends on the path through which the system changes its state. I think you have understood what is state function and what is path function. State function depends on the initial and final. Path function depends on the path through which system changes its state. Next topic, thermodynamic properties. Again, there are two types of thermodynamic properties. One is extensive property, another is intensive property. Extensive property and intensive property. Suppose this is a bucket containing or beaker containing 20 liter of water. So this is a system containing 20 liter of water. I repeat, this beaker or this bucket, this container containing 20 liter of water. And also, suppose temperature of the water is also 20 degrees centigrade. 20 liter water and temperature of the water is also 20 degrees centigrade. Now, what will be the temperature of 1 liter? Obviously, it is not 1 degree. So, temperature of the 1 liter also 20 degree. Even one drop of the liquid also 20 degrees centigrade. 20 liter of the water is 20 degree. 1 liter also 20 degree. One drop is also 20 degree. That is now the temperature. See, the temperature does not depends on the amount of matter present on the system. Whether it is 20 liter, whether is it 1 liter, whether it is 1 drop, temperature remains same. This temperature, this is a temperature whose magnitude does not depends on the amount of matter present on the system. Now those property does not depends on the amount of matter present on the system is called our intensive property. I repeat, those property like temperature does not depends on the amount of matter present on the system is called our intensive property. So example is our temperature. More example is our density. Density is also density of 1 liter same, density of 1 drop is same. So if we know this, you can easily define this also. Now those property which depends on the amount of matter present on the system is called extensive property. For example, now what is the volume in this? What is the volume of water here? 20 liter. Now add more 20 liter of water. What will the volume now? Volume now become 20 plus 20 equal to 40 liter. Now volume depends on the amount of matter. Earlier volume is 20. You added more 20. Now volume become 40. That is volume depends on amount of matter. So volume is our extensive property. Similarly, mass. Mass, you take your weight. Suppose 60 kg. After taking some 2 kg of food, your weight will be 62 kg. So again, mass is also a extensive property. So today, up to this today, next class we have discussed as thermodynamic processes. So thank you for the watching this video.